Hey folks, so this is the first of a series of 3 videos from section 4.1. We're dealing here with polynomials. A polynomial is a function that has a higher degree. We'll talk about what higher degree means here in just a moment. First of all, we're going to deal with some terminology. My suggestion is that you would pause the video after each definition and answer the question that comes after the definition. All right, so here we go. Refer back to the very ugly example that I've placed at the top of the screen to be able to answer each of your questions. So the first term is term. These are going to be parts that are separated by positives and negatives, or by pluses and minuses. So my suggestion now is to pause the video and just answer, how many terms do you have in this example? The second definition is degree. This is going to be the highest power in my polynomial. Third, the leading term. This is going to be the whole entire term that has the degree inside of it. The coefficient is next. The coefficient is the number that's multiplied by the variable in each term. The leading coefficient, this is the fifth definition. The leading coefficient is going to be the coefficient inside the leading term. The coefficient inside the leading term. The constant, this is going to be the number that's standing alone, the number that has no variables inside of it. So again, take a minute to answer each of those questions about the definition and use the example that's at the top of the page to answer those questions. Some properties of polynomials. Polynomials are always going to have a domain of all real numbers, negative infinity to positive infinity. Polynomials are also always going to be continuous. Continuous just simply means that you can draw the whole entire thing without ever lifting your pencil. The third property of polynomials is that they're always going to be smooth. In other words, there's no sharp corners. Do you remember back in our parent graphs, the V graph had a sharp corner on it? That is not a polynomial. Polynomials are always going to be nice, smooth curves.